says, so to find the slope of the graph at a point x f of x, we want to look at the slope of the secant line as delta x gets smaller and smaller, or as delta x approaches 0. That is, we want to consider, now here's what we bring in the previous chapter, we wanted to consider the limit as delta x approaches 0, or if you use the one that I did, we would say the limit as h approaches 0. Again, it's no different. Delta x is h. It's the exact same picture, but the difference is a lot of students make fewer errors when you write h instead of delta x. They get screwed up combining x's and delta x's, and those aren't at all the same thing. So that's why I like those h's. So it says, if f is defined on the open interval containing c, and if the limit is delta x approaches 0 of change of y over change in x, which is the slope of the secant line, equals m exists, then the line passing through c f of c with slope m is the tangent line to the graph of f at c f of c. So what did they just say? They said, if that limit exists, if the limit as h approaches 0, let me actually go down. It's really right here, right? So it says if this limit exists, the limit as h approaches, or delta x approaches 0, of f of x plus delta x minus f of x all over delta x. That's called your difference quotient, the limit of the difference quotient. If this exists, this is your slope of the tangent line. Again, though, I like using this other formula. I like using the limit as h approaches 0 of f of x plus h minus f of x all over h. I think x's and delta x's again get combined, mess students up. H's make it a lot cleaner and a lot easier. So if you want to use the h version, I highly consider it. It would be the limit as h approaches 0 of f of x plus h minus f of x all over h. I want to highlight this, and I'm going to write something. It doesn't make sense to you right now, but it's really, really important. I want to write definition of derivative. Definition of derivative. This is the slope of the tangent line, the definition of the slope of the tangent line. It's also going to be the definition of a derivative. This is absolutely vital that you understand it. Again, you could use either version of it, the red version or my highlighted yellow version. I don't care, but it's extremely important that you know that. It says in some books they might talk about the slope at a given point where they actually give you the number c and f of c, and you would actually just plug it into here. So this would be like at the point 2. So the first ones are more in general at an x. The second one would be at a single point 2. I always like doing it the first ways, at general and with an x in there, because if you do it in general with an x in there, you can plug in any point that you want, like 2, -2, 5, and all you have to do is the math once. Whereas if you do it the second way, where you plug in the number 2 right at the get-go, right at the beginning, you have to, and then they ask you to plug in another number like 3, you'd have to do the entire limit process again. So if you do it in general with x's, you do the limit process once, you can plug in as many numbers as you want. If you do it without the general, with a given point, you'd have to do it the entire limit process every single time you want to evaluate the slope of the tangent line. So how do you find the slope of a tangent line? Well, I'm going to teach you guys how to do it in steps. It's important that you understand this. I'll teach you how to do it in steps, but then I'm going to do it all together in line as well. So I'm going to break it into these individual steps, and then I'm going to also do it in line as well. So the first thing you want to do is find f of x plus h, which is that first part right here, right? Find f of x plus h. The second thing that you're going to do is subtract off f of x from that. So whatever you got and simplified, subtract off f of x. You want to simplify it again and factor out an h if possible. Then the third thing you do is you divide it by that h, simplify, and then the last thing you do is you evaluate that limit. So you don't evaluate the limit until the very, very end. First find f of x plus h, then subtract off f of x, simplify, factor out an h, divide by h, and if you factored out an h, those will simplify. A lot of you say cancel, but it's technically simplify. And then you evaluate the limit, okay? If they give you a specific value that they want it at, like at x equals 2, only then would I plug in the x value. So this is a process we're going to do numerous times. I want you to practice doing this. It is extremely important that you show every step of the process. Let me say that again. You must show every step of the process. Very, very important for you to understand that. You have to show every single step.